Welcome back to a fresh week of Digital Dispatch. Hope you had a fantastic weekend.
Hope so too.
We're always curious, what were the coolest new tech stories that caught your eye over the past few days? Definitely let us know in the comments below.
Yeah, always great to see what everyone's buzzing about.
Well, today we're diving deep into something that kind of combines childhood nostalgia with some really cutting-edge AI. We're
Yeah.
talking Lego building.
Lego. Can't beat it.
Right. And this is the kind of discussion we really hope you'll find interesting enough to, like and share with others who are curious about where play meets advanced tech.
It's a fascinating intersection for sure.
So let's jump in. We're looking at this new AI at a Carnegie Mellon University called LegoGPT. What's the big deal here? What makes this one special?
Okay, so LegoGPT. It's an AI model from CMU researchers. And its main goal, the really crucial thing, is creating Lego designs from text prompts.
Okay, like build a castle or something.
Exactly. But designs that aren't just, digital pictures. They have to be physically stable. You need to be able to actually build them in the real world. That's the key innovation.
Right, because I guess a lot of AI can whip up amazing 3D models visually, but you're saying if you tried building them with actual bricks, disaster.
Precisely. Many current models are fantastic at generating really complex, visually interesting 3D objects on screen. But the problem pops up when you try to make that real. The researchers themselves said, without thinking about physics, parts of the design can just collapse or float weirdly or just be disconnected pieces. Imagine like an AI designing a bridge but forgetting about gravity.
Huh. Yeah, okay, that paints a picture. So Lego GPT tackles that specific problem.
It does right from the start. Its core focus is physical stability and, well, buildability. So the models it spits out should actually stand up, whether you build them by hand or maybe even a robot does.
Okay, this is where it gets really interesting for me.
Yeah.
How does it manage that? Designing is one thing, but designing something that won't fall over, that seems tricky.
Yeah, it's pretty clever. The magic is kind of in its next brick prediction approach. It basically repurposes the tech behind large language models, LLMs, like ChatGPT.
Okay.
But instead of predicting the next word in a sentence, LegoGPT predicts the best structurally sound next brick to add to the model, based on the prompt and what's already there.
So it's like teaching AI the grammar of gravity using Lego.
That's a great way to put it, yeah. They fine-tuned LaMMA 3.2 1B Instruct. That's one of Meta's instruction-following models. They taught this language expert how to follow building instructions, specifically for Lego.
Yeah.
But that's not all. That brick prediction works alongside a separate software tool, and this tool is constantly checking the physical stability using mathematical models, simulating gravity, structural forces, all that stuff.
Wow, okay, so it's not just guessing brick placement, it's running physics checks.
Exactly. It's
Yeah.
using physics principles to make sure the virtual Lego creation has a good chance of standing up in reality.
That makes a ton of sense. So how did they teach it these physical rules? You can't just feed it a physics textbook, right?
Like, they had to build a whole new training data set. It's called Stable Text to Lego. And get this, it has over 47,000 unique Lego structures.
47,000.
Yep. And crucially, all of them have been verified as physically stable. Each one is paired with a text description, a caption.
Generated by another AI.
You got it. They used OpenAI's GPT-4o for the captions, focusing just on the geometric features, like the shape and structure, not the color.
Okay, so a huge library of stable Lego models with descriptions.
Yeah.
But how did they know all 47,000 were stable? That sounds like a lot of testing.
It was a critical step. Every single structure went through some pretty rigorous physics analysis to confirm it could actually be built. And to get good descriptions, they fed GPT-4o images of each structure from 24 different viewpoints.
24 angles, wow.
Yeah, presumably to give the captioning AI a really solid 3D understanding of the geometry it was describing.
That's some serious virtual Lego building. Okay, so it's trained. What happens when you actually ask it to design something? How does it put the bricks together?
So LegoGPT generates a sequence, like a step-by-step plan, showing exactly where each brick goes. As it adds each new brick, the system checks, okay, does this clash with anything? Does it fit in the build space, which right now is a 20 by 20 by 20 area.
20 studs, square and high. Okay.
But then the really clever part, after the design is done, or even during, those physics models kick in again to verify if the whole thing can actually stand up without tipping over.
What if it designs something wobbly? Does it just give up and say, try again?
No, and this is super important. They developed something called physics-aware rollback. If the system detects instability, it doesn't just scrap the whole thing.
Ah,
It figures out the first brick in the sequence that caused the problem, then it removes that brick and everything added after it and tries a different path from that last stable point.
so it can undo and rethink, like a person would.
Kind of, yeah. It's iterative learning and correction for physical design errors, and it made a huge difference. The researchers said without rollback, only about 24% of designs were stable. With it, 98.8%.
98.8, that's basically all of them. That's incredible.
It really is a game changer for this approach.
So with that kind of stability sorted,
Mm.
what can it actually build right now? What are the limits?
Well, like I said, there's that 20 by 20 by 20 space constraint. And it's currently using a limited set of just 8 standard brick types, your basic blocks, mostly.
Okay, so maybe not super detailed models yet.
Right. It limits the complexity and, the fine detail. But the researchers know this. They plan to expand the brick library, add more sizes, slopes, tiles, all those bits that make things like smoother or more complex.
Makes sense.
And the training data covers 21 object categories right now. That's a decent start, but they want to scale that up significantly too so it can generate a much wider variety of things. Think of it like it can build a solid basic car, but maybe not a super detailed replica yet.
Got it. A strong, stable foundation, but still early days for complexity. Now, the big question, did they actually build these things? To prove it wasn't just stable in the computer.
They absolutely did. This is the cool part. They used a dual-arm robot system.
Robots building Lego.
Yeah, with 4 sensors and everything. The robot followed the AI's step-by-step instructions and successfully assembled the models. It was a crucial proof of concept.
That's amazing. I'd love to see a video of that.
And it wasn't just robots. They also had human testers build some designs by hand.
Oh, good. The real test.
And they were successful too, which confirms these are genuinely buildable models. They also benchmarked LegoGPT against other 3D creation AIs like Llama Mesh.
LegoGPT came out way ahead on stable structures. Really highlights that physics-first approach.
So it's not just about looking good, it's about working in the real world. And I heard they added color and texture now too.
Yes, that's a newer feature. They've expanded it so you can add appearance prompts. Like, you could ask for an electric guitar in metallic purple.
And the AI will generate the stable guitar shape and assign the purple color to the bricks. Adds another layer of creativity.
That really does open things up. It feels like this is more than just a fun project, right? It has bigger potential.
Totally. And recognizing that, the team has actually released their data set, the code, the trained models. It's all open source on their website and GitHub.
That's great.
Yeah, they want others to build on this. The fact that the data is based on stable designs is key. It allows the AI to learn those physical rules, which could apply way beyond Lego.
So stepping back, what's the big takeaway here? It's not just AI playing with toys, is it?
Definitely not. It's a real step forward in AI understanding and generating designs that actually obey physics. Think about architecture AI helping design buildings that are sound from the get-go.
Or robotics.
Yeah,
Designing robot parts that are stable.
exactly. Or even rapid prototyping. You could design and print physical prototypes with much more confidence they'll hold together. It's AI bridging the gap between digital design and tangible, real-world objects.
It really offers a glimpse into AI helping us design and build things more reliably, more intuitively.
For sure.
Which brings us to a question for you listening. What other areas could really use AI that understands physical limits like this? What other, maybe seemingly simple tasks could this kind of approach totally change? Definitely something to chew on.
Yeah, lots to think about there.
Well, thank you for taking this deep dive with us into AI-powered Lego. We hope it sparked some curiosity, maybe gave you a new perspective on AI and the physical world.
Hope you enjoyed it.
We wish you a wonderful week ahead.
Yeah.
And definitely keep an eye out. We'll keep bringing you more of these cool, optimistic science and tech stories.